So if we look at the first problem is knowing that electron charge is equal to this amount of Coulomb. So calculate how many electrons in 1 Coulomb. So this is a very straightforward problem, and most of you have already got that answer, right? So this is basically the charge of 1 electron. So 1 Coulomb is 1 over, like, how many electrons do we have in 1 Coulomb? So if 1 Coulomb becomes this, then number of electrons is basically 1 over this. So the answer will be 1 over, like, 1.6 times 10 to the power minus 19. So this 10 to the power minus 19 is basically charge of 1 electron. So whatever result you have here, that should be your answer. And here the similar kind of problem, how many electrons are passing through a conductor per second when you measure a current of 1 ampere in a conductor. So 1 ampere means 1 Coulomb per second, right? So 1 Coulomb per second. Now you already know how many electrons are there in 1 Coulomb. So how many electrons are passing through that 1 Coulomb? That's the same answer like the first one. So it's all the same. The second problem also have the similar answer. I mean, same answer. Now come to the point here. Define power in words and with an equation. So what is electric power? Electric power is, okay, if you have a circuit here, and for example, you have a circuit element here, R4. What is the power in R4? That power is coming from this source, right? So whenever this one is receiving some power, it is kind of receiving some energy, and that energy is utilized here in R4, maybe either in the form of heat or light or something else. So it is spending energy per second. So your answer here should be like the rate of energy dissipation, or like per second. So that should be your answer. So dW over dt. So your answer should be, so for the second question, your answer should be like this one, dW over dt, right? This is basically your power. So this is also straightforward, and most of you have already got it. Now the second part, how many joules per second are consumed by a 100-watt light bulb? So already you know that this W is basically in joule, and this T is in second, right? The unit, and this unit is power, I mean watt, right? So how many joules per second are consumed by 100-watt light bulb? So what are the like constants here? Like 1, right? So 1 over 1, kind of, you can say that 1 watt is equals to 1 joule per second, right? Okay, so 1 joule per second. So there is no way to get this like 100 to 1000. Some of you have got 100 into is equal to 1000. So if 1 watt is 1 joule per second, then 100 watt is basically straightforward 100 joules per second, right? So this is also very simple. Some of you have answered 1000 joules per second. I don't know how you got this one, but this one is wrong. Now for the next problem, this one, given that the polarity in the figure, draw the positive direction of current. So I'll just snip this one in the new page. So for this problem, I'm wondering why you have made mistake here. This is very well-known problem, and I have also solved this kind of problem in the lecture class. So given the polarity, so polarity is already given. Draw the positive direction of the current according to the passive sign convention rule. So one problem here is this is not mentioned whether this is actually a power generator or power consumer. So we are hoping that this is a resistor. So given that resistor, we already know that current should always flow this way. If like current should flow in the positive from positive end to the negative end, because we used this formula in every like KVL, right? Where you have used KVL, so current should always flow from positive direction to negative direction, and then you have a voltage drop here, right? So whenever there is a voltage drop, we say that the plus is here at the A terminal and minus is here at the B terminal. Now, given the reference current direction, define the polarity of the elements in the figure. So what is the difference between these two? Once you get this one correct, there is no way you will make mistake here, right? This is also very simple. So obviously this is plus and this is minus. But some of you have written, okay, positive or something, you have written blah, blah, blah. But if you give only one sign here, not even here, not even here, you give something here. So that's a mistake, right? That's a wrong. So correct answer should be this, because already you know the answer. You have made the first problem correct. So you should have made the second problem correct as well, because there is no difference. Now come to this problem. So this one, again, the sign convention, right? So for this problem, what we are expecting you to give is calculate the power in each element, the first portion. And second portion, determine whether the elements consume or generate power. So some of you have made mistake. Even with that mistake, I have provided full points, but some of you have not. So what is the passive sign convention? You already know. The passive sign convention you already know is if there is an element like this and it has a positive terminal here and negative, like if it is a voltage source, for example, it's an element, not a voltage source. VAB, for example, you have here. So A terminal and this is B terminal. Now, we always expect that current is flowing from this side. So this is a positive current, right? So the voltage here is positive if terminal A has higher potential than B, and current is flowing from terminal A to terminal B. Now, for every element, like resistive element or any capacitive or inductive or something, so far you have already known that resistive only, right? Think about a resistive element is receiving power, is consuming power. So that should be in this shape. Now that is exactly matching here. Your plus sign is here, your minus sign is here, and your current is flowing from positive to negative, right? So what is your current, power here? So P should be equals to 3 times 4, right? Very simple. 3 times 4 is equal to 12. So this is again plus 12, right? So plus 12, I am not mentioning plus. So whenever there is a plus, obviously this one is consuming power. Now, if this one is consuming power, what about the second one? What is the difference between the first one, A and B? I see no difference because this circuit is flipped vertically to get this one, right? Because this plus is here and current is flowing from this terminal to upward, or maybe exiting this way. So exiting from this terminal is similar to entering to terminal here. So again, the same answer is applicable here. So I was expecting you to write down obviously 12 watt plus 12 watt. Don't make mistake. Like you don't need to write down like only the 12. Okay, 12 is here, okay, but in other cases, whenever you are seeing that generating power, you have to write down the symbol here, like sign, positive or negative. So these two have basically the same answer. So both of them are consuming power, right? But come to this C here. In C, we are expecting, okay, this one is the positive terminal and this one is negative. Now, current should enter through the positive terminal, should enter from our understanding if it is a power consumer, but it is not happening. So we are hoping that current is entering from positive terminal, then the current should be minus 3 ampere, right? Minus 3 ampere times, what is the voltage here, times 4 equals to minus 12. So think about it. We are hoping that current is entering from positive terminal, and that current should be like, okay, 3 ampere is showing outwards. Now, if we make it like inward, it will be a minus here. So this minus 12 watt, that means it is generating power, right? Any confusion? So generating power, blah, blah, blah here. Anyway, so I was expecting you to give this symbol, of course, this plus or negative, I mean plus or minus sign, plus this number here, because you have been asked to calculate the power and then determine. So if you have made this one correct but this one wrong, I have deducted like minus 2 for this. So I basically split it into like 2 and 2. Sorry, 1 and 1. So if I make any mistake in judging your script, please let me know. And this one, the last one, D, is also like similar to the C, right? What is the exception here? Okay, so this is the positive terminal. So current is entering this way from the negative terminal. That means current is exiting through this positive terminal. So the same problem here, only these two are flipped, right? This one and this one are flipped. So the same answer is applicable for this one as well. Okay, now come to the next problem. Write down KCL equations for this. Okay, the KCL equation here we have to write down. You already know, right, like KCL equation. So some of you have made mistake like KCL and node analysis. What is the difference? Anybody else can please tell me no? What is the difference between KCL and nodal analysis? Okay, if you don't know, so nodal analysis is an application of KCL, because in nodal analysis we think this point has a potential like V1 maybe, and this point has a potential of V2, and this entire node has a potential which is basically grounded. So we think about this one is grounded, right? And you write down the expression in nodal analysis in terms of voltage, but that voltage is basically you are considering currents. So if you have written nodal analysis here, that's wrong. You have to write down simple KCL equation because the currents are already given here. I1 is flowing from like through this R3, and I2 3 milliamps and 4 milliamps. Now, how many how many KCL expression is required for this circuit to solve? Any idea? Okay, 3. That's right. Because you have already learned that some of the formulas. Anyway, so think about it. There is no current given here. Like only I1, I2, I3, I4. In this way, these currents are given. So you have to write down, for example, if you want to write down mesh analysis, so you have to think about one current is here, another current here, another current here, right? So you have to write down 3 expressions. So similarly, like to KC, if you want to write down KCL, you have to think about this one node here, node 1, this one node here, node 2, and what is the other node? Other node is entire this downside, because all of them are connected here with the cable, but without any other element here. Some of you have written this is N3 and this is N4. So what is the difference between N3 and N4? There is no difference. Because if there is no elements connected here or here or here, then entire like bottom side is one node. That is, we will say node 3. So node 3. Now, if you have missed this node 3 expression like of KCL, then I have deducted 3 points, because total 10 points. Anyway, so you already know what is the KCL at this node 1, right? I1 is entering, I2 is exiting, and 3 milliamps, this one is exiting. So all the current entering is equal to current exiting. The first one will be I1 is equal to, very simple. So I don't know why you guys make mistake here. So 3 milliamps plus I2, right? So this is very straightforward. But most of you have got this one correct. That's good. So the same kind of theory is applied here at node 2. So, okay, some of you have written in this format, but it is also true, right? If you bring this right side into left side, then put equals to, you have to put equals to 0. Like severe mistake. I1 minus 3 milliamps minus 12, sorry, minus I2. So if you rewrite this expression in this way, you have to give a 0 here. Very important, because this is an equation. So if you write down without 0, that's a mistake. So same thing here in node 2, current entering is equal to current exiting that node. So basically 12 milliamps is equals to 4 milliamps, and I1 is exiting. So 12 is equal to 4 plus I1, right? Anything else? So obviously 4 and 12 are in milliamps. So milliamps is entering here and exiting I1 and I4. So that's the thing. And the third one, you have 1, 2, 3, 4 currents. So this current is exiting only, and all of them are entering. So don't make mistake, like sum up all these 3, I2 and 4, and then equals to 12. So that equation will be 3 plus 4 plus I2 equals to 12. Obviously these are in milliamps, so that's for node 3, right? So I'm using mouse, so the writing is not good enough. So I hope you understand. Anyway, but the point here, find out the value of I1 and I2. The good thing here that you have already given, you have been given these 3 milliamps, like a lot of the current are already given. That's why you don't need 3 equations to solve those like unknown quantities, right? I1 and I2. You only need for node 1 and node 2, and most of you have made correct, is like 8 milliamps and like another one is 5 milliamps. So if you solve these two, and you will get like this one is basically 12 minus 4. So 12 is entering. So I1 is equals to 12 minus 4, 8 milliamps. I'm writing it here because I need this to solve the next part. So that one is 8 and that one is 5 milliamps. Now calculate the voltage over R3, 2 kilo ohm. Okay, this one, most of you have made mistake here, like in 3. So what is the problem here in C actually? So R3 is 2 kilo ohm, right? So I'm erasing some part here because I don't need this here. Now you already know your currents I1 and I2. So you should be very comfortable in writing this, the current voltage over R3. Okay, you know the KVL. KVL is applied in a closed loop or closed mesh. You can think about mesh or loop. And you will assume a current flowing through each element. If the current directions are not given, you have to indicate the current direction, right? So, but the currents are already given here. So, based on that given current, like this is a voltage source. Usually what you have learned so far you have learned that you go through the elements in clockwise direction, right, in this direction. Okay, so either way is fine. You start from one point and then go for another, go finish the entire loop. So it's easier for you to write down equation in reverse way. So start from this node 3 and you see a voltage source right here. So you'll see minus 20, sorry. So minus 20, you got that right. And then this current I1 is flowing from right side to left side. So what is the symbol here? Like plus here and minus here. There is a voltage drop, but it's a plus, right? So plus 8 milli times 2K, right? And then you come up here in across R2. So R2 is again 5 times, so current is flowing from top to bottom, so plus here and minus here. That means another drop here, so plus 5 times R2. What do we have to find out? So R3 is this, right? So from this expression, you can easily find out R2. Now, if you find out R2, you don't need to find out I2. Sorry, I'm solving a different question maybe. Okay, so what is the voltage over R3? So already you know the resistance, you know the current, right? So that's 8 times 2, actually 16. This one is straight for 16 volt. I'm sorry, I was solving the other problem maybe. Oh, I was solving this one actually. Anyway, so this one is very simple, like 16 volts. So you don't have to calculate anything. It's just V equals to IR, Ohm's law, right? Why don't you make me correct? Anyway, what can you say about the connection of R1 and R2? These R1 and R2 are connected in parallel because this is one node here and that another node is right here. So there is 2 elements are connected and 2 nodes here. So one element here, one element here. Obviously, they are connected in parallel. Now, if the voltage source supplies 20 volt, calculate the resistance R4. This voltage, okay, voltage source is given 20 volts. You have to find out the resistance R4. Now, tell me, this voltage source and R4, how are they connected? Any idea? So these two elements are connected in parallel because node 2 and node 3, in between node 2 and node 3, these two elements are connected in parallel. That means whatever voltage, yes, in parallel. So whatever voltage you face here across this node 2 and node 3, that same voltage is applied across R4. So if you want to find out the resistance R4, you know that V equals to IR, right? So V is equals to 20 volts equals to, you know the current here 4 milliamps, 4 milli times R4. Now this is very straightforward. You will get R4 is equals to 5 milliamps, right? So 5 kilo ohm, because 20 over 4 milli is equal to 5 kilo ohm. There is no way to make mistake here again. Any problem to understand this problem E? And this one is basically here. Find the voltage over R2 here, R2 using KVL. Now that KVL, I'm again coming here. Start from any point and you already know the direction of current in every branch. So you know the notation, passive sign convention notation, and you go through this one, right? You will get this one, and that will be equals to 0. Now, if you already know every element here, now only you have to find out this R2. So 8 times 2 is 16. Now from here, R2 is basically equals to 20, and this is 16. That means if you go this way, and then 4. Is it 4? Okay. 4 over. So this is 5 millions, right? So I think you know how to solve this one. If I am not mistaken with any of the values. And then you have to find out the voltage. Okay, then the voltage is basically 5R2. So directly put 5R2 then. Yeah, that's right. So you have to find out the voltage over R2. So just find out this value. This value is equals to 4 volts directly. There is no confusion. Sorry. Thank you. So just put what is the value of 5R2? There is 4 volts. Now, is the voltage over R2 and R1 are equal or different? Obviously, this node 1 and node 3, these two elements are connected in between node 1 and node 3. So obviously, they should have the same voltage, right? Equal voltage. Calculate R1. You already know what is the voltage across this, right? Across these two. So now, if you already know the voltage across these 2 points, what is the voltage here? 4 volts, right? Maybe, yeah. So 4 volts. So you know the voltage is 4 volts. So 4, and then the resistance. So R is equals to V over I, right? So I is 3 milliamps. So equals to 1.33 kilo ohm. This is also straightforward. So some of you have got like mistake here because you have made mistake maybe here because these are connected, right? These two are connected. If you make a mistake earlier, then you will get mistake in the last one actually. So I think that one was easier. and GH is done. Looking at the figure, what can you say about the relationship between R4 and R5? So where is R4? R4 is right here and R5 is right here. So these two elements obviously not in series and they are not in parallel because they do not share common nodes. Okay, I'll snip it and okay, so when two elements are in parallel, they share a common node. There are two common nodes actually. How? So this is node 1, this is node 2. So if they are connected in this way, like one element's here, another element's here. So node 1 and node 2. I will say actually these two elements, if they are connected in between two nodes, then they are parallel. Now let's find out the nodes here. One node is here, right? Another node is this entire stuff is actually another node, node 2. Now there is another node, say this is node 3. And this entire part is basically creating another node, node 4. Now, very straightforward, these two elements, R4 and R6, are not connected in between two nodes. Although they are sharing node 4, but they are not sharing node 2. So they are not in series, not in parallel. So that should be your answer, right? Neither parallel nor in series. If the lower node is reference node, what is the value of VA at node A? So if this node is basically the reference node, then reference node voltage is 0, right? And what is the value of VA? So there is only one element in between these two nodes. So this node voltage is minus the lower node voltage. I mean, node A minus reference node is equal to this voltage, this branch voltage. So basically, you have connected like 12 volts in between these two nodes. So that's your answer, like 12 volts, straightforward. There should be no confusion. And most of you have got this one correct as well. Now, if the currents in R5 is 5 milliamps, what is the value of VB at node B? Which one? Node B. Okay, node B here. What is the current here? IR5. So this one is given. Right. So IR5 is given. Then if IR5 is given, the value of node voltage here will be the product of current and voltage here. So 6 times 5 milliamps. That should be your answer. So 6, obviously 6 is in ohm and current is 5 milliamps. So the answer obviously, so this is ohm and this is milliamps. So the first thing is answer should be either in volts or in millivolts, not in ampere. So some of you have written ampere here. There is no way. This is wrong. You have to write down the correct unit. You are saying like you want to buy, for example, some liquid. You have to mention that I want to buy 1 gallon or 2 gallon or liters, right? You should not say I need 1 inch liquid, 2 inch liquid, something like that. So current is ampere and you are finding out the voltage VO. is equals to, that should be in volts, not in ampere. So why do you make this kind of mistake? I don't understand. And another thing, 6 and 5, obviously 30, right? So 30, and you see this one is in ohm and this one is in milli. So that should be millivolt. Either this millivolt or maybe 0.03 volts. So either one is fine. Either 30 millivolts, but 0.03 volts is also fine. This one is easier for all of you. The delta Y conversion, RA, RB, and RC. So do I need to solve this one? I think you have, most of you have got this one correct. So one thing, you want to find out the voltage, current, resistance here, right? So now, if you want to find out this one say, for example, this one is RA. Actually, RA should be in this one, actually. So your problem is given here. It is mentioning this one is RA. That's why I'm writing RA here, RB here. But actual notation, the opposite branch of R1 should be RA, and opposite of R2 should be RB. Anyway, it doesn't matter actually if you get the things correct. So RA is equals to, the easiest formula is, if you want to find out the resistance here in between two resistors, so multiply those two, R1, R2, and then sum of all three connected in delta, R1 plus R2 plus R3. Simple. If you want, I'm telling you again, you don't have to memorize all the formula like here. Although the formula is given, so you don't have to worry about it, right? So R is equal to R1, R2. Now, you want to find out the middle branch here. So then multiply this associated two resistors and then divide by all the sum. You want to find out the value right here, then multiply R2 and R3 and divide by all of them. So as this is already, the formula is already given, I'm not going to solve it. So that's just put the values there and you will get it. Now come to this point. Now you have replaced the delta with Y. That means this delta connection right here, this delta connection has been converted into Y right here. Now RB and, okay, so what is the relationship between RB and R5? So R5 is here, RB is here. Now, some of you have made mistake here. I don't know why, but let me clarify this one to you, how these circuits you are treating. So don't get confused with this V output. There is nothing, no element here, right? So this plus and minus sign is basically to connect to check the voltage across R5. So these R5 and these RB2, they are sharing their hands here. One hand, and other hand is connected in two different nodes, because this is one node and this is another node. So two elements are connected in between these two nodes. So they are connected in series. Now, can you please tell me how element RB and RC is connected? These two, how are they connected? If you get this one correct, then I will understand that you know this. No idea? RB and RC? No, not parallel. Why not parallel? I will tell you. Because this RB element is connected in series with R5. That is the first thing. RB and R5 in series. These two are in series. Now, once these two elements are related here, and now they are sharing these two nodes, right? So node C, and node like ground, and then they are connected in this way. One here, another is here. So these two are neither connected in series nor in parallel. But if you think about the combination of these branches and this RC, then they are parallel. Other than that, directly RC and R5 neither parallel nor series. Similarly, RB and RC nor series, neither series nor parallel. The same thing is true for RA and RC as well, because these two guys are already in a relationship here, and keeping this relationship true, then they should have built up other relationships like series, because this is already series. Then if anybody else is coming across this, obviously he has to build up relationship with both of these elements because they are already connected in series. Okay, so the final answer is here. These two elements are connected in series. Now the last one, still if you are anyone is confused, please let me know the series parallel thing, because this one is very vital in solving any kind of circuit. Okay, the last one. Last one is very interesting, and most of you, I mean 50% students have made mistake maybe, but I didn't expect this mistake. So source superposition, and this is your circuit element. So as this one is vital, please listen carefully about this one. So source superposition means you are turning off one source. Okay, I didn't make it, but I can make a key for the test paper. Okay, so these two elements are connected. In series, and then if you simplify the source superposition. Now think about only this one and omitting this 2 milliamps. Now you have to find out voltage across these two terminals for one source, and for another source you have to find out voltage across this 6 kilo ohm, and then you have to add them up using source superposition. So the first one will be these two here, and think about this voltage source and this one is open, and you have 1 kilo ohm here. So 1, 2, okay, this voltage source you are thinking minus plus, and this is 3 volts, and this is 6. Now you have to find out the voltage across these two terminals. So we are saying this is VO1. VO1 is how much? So 3, 2, and 1. All elements are connected in series, right? So if they are connected in series, now how much voltage is across this 6? Okay, 2 and 1 combinedly can make this branch like 3 ohm, right? Think about it. I'm just omitting this one, using this one. So nothing else here. Think about this is 3. Now the voltage divider rule you can apply. So you are trying to find out the voltage across 6. So 6 times the current is basically 3/9, right? So how much? 332, 2 volts. Now, alternatively, if you want to find out the, so V1 is done. Now, the notation is important here. So you are thinking current is going from this positive terminal to negative terminal. That means you are okay. And the second one is omit this one and use only the current source. So if we rewrite the circuit right here, so again, this 2 kilo ohm and 1 kilo ohm in series, so I am replacing it with this 3, so don't like misunderstand. So this is 2 milliamps and going upward. Now this one is shorted and now you are left with this one is shorted. So VO2 is equals to I6 times R6. We are thinking this one is R6. Anyway, so these 3 ohm and 6 ohm are connected in series or in parallel for this circuit. Any idea? Parallel, right. So you have to use the current divider rule. The current divider rule to find out what is the current flowing here, right? Because current is flowing upward here, upward direction, that current should come this way. That means you are good to go with the symbol, I mean plus minus. But what is I6? I6 is equals to always, if two branches are connected in parallel and you want to find out the current through that particular element, so multiply with the other resistor. So total current is 2 and then multiply with the other resistor 3 and divide by the sum. So 9. What is that? Okay, 3, 3. So 2/3, right? 2/3. Now this one will be equals to 2/3 times 6 equals to 4 volts. Now you got VO1 and VO2. And now these 4 volts again from top to bottom, now they will be added up. So total voltage will be 6 volts. So V out is equals to 6 volt. Now, if you think that this V out is a correct answer with this first method, what should be the answer in the second method? 6 volts, right? So some of you have made mistake that you are using like same circuit, you are trying to find out the same component or value, but you are making mistake, 2 different values for 2 different circuit. Don't make this circuit very complicated. So if you make it complicated, then you will make wrong and you will make mistake. So the second one is much easier, source transformation. So in terms of giving you credit, source superposition, at least if you have made like the first step or second step clear, or maybe you are correct with the circuit, you have shown the circuit clearly and you have put the value, I have given you partial credit for that. I think most of you have got that. So I am solving the last one, B. I'm already out of time, so but B is again like source superposition, source transformation, right? So think about this part here. These two are elements connected in series. So series means 3. Now this 3 is again in parallel with this current source. And then you have a voltage source here. So 3, this is 2, and now you have this 6, right? So the first thing is you got this one. Now these 3 and 2 milliamps, this one is obviously milliamps, are connected in parallel, right? So think about the Norton's theorem. So they can be, this portion can be transformed first. How? You got a series voltage source and a resistor, right? And then you have another voltage here, 3 volts, and then you have another resistor here. So now, what is the value of this voltage source? So that should be 3 times 2, 5. The resistance in kilos, so 5 volts. Sorry, 6. So 6 volts. And what is the value here? 3. Now you have 6 here, and this is a voltage source. Again, now these 6 volts and 3 volts, they are in the same direction. So basically, plus minus. So this is one source and another source here. So plus minus. So similar, like these two are connected in series. So in the next part, you can easily say that they are connected in series, and you can replace it with only one element here. So that is 9 volts, right? And you have a resistance here, you have another resistance here. So 6 kilo, and this one is 3 kilo, and this one is how much? 9. So 9. Okay. You have 9 volts and you have total 9 kilo ohm resistance, 3 and 6. So each one should share at least their like fair share, right? 1 volts per resistor. That's a simple thing. So 3 plus 6 is 9, and you're sharing 9 volts. So every resistor will get 1 volt. So this voltage divider will give this one is 6 volts, right? V is equal to 6 volts. So the same answer we have got for 2 ways. So is it clear? Like these 2 elements are connected in series, use voltage divider rule. Using source transformation, we got this one. So thank you for your patience, and thanks for your questions. Because okay, any idea on what to expect on next exam? I have no idea, because Professor Hasan does not share what is he giving in the next exam. So you can shoot an email directly to him. So what is the answer for that one? So that one is 6 volts. Yeah. So 6 volts always. Same circuit. So you want to find out the voltage across the same element. So you should get 6 volts, right? Use just voltage divider rule here. So VO is equals to 6 times the 6 over, okay, so 6 plus 9, so right, 6 times 9, actually this one will be 9. So this is equals to 9 times 6 over 9, because total resistance is 9 here. So equals to 6 volts. Okay. Did you upload the key to the canvas? No, I have not made any key, but I'll try to make one, and I'll send it to the professor to upload it there. Yeah. Any more questions? Okay. Then thank you so much. Have a great weekend, and next week I will not be available here, but maybe Professor Hasan will take this class next week, because I have some business with other things. Yeah. You all have a good weekend. Bye.